When historians describe the great world's fairs of the 19th and early 20th centuries, they often frame them as temporary celebrations of progress, moments when nations gathered to display their latest inventions and cultural achievements. On paper, these fairs were meant to be short-lived events, lasting a few months or a few years at most. Yet, when we examine the photographic record left behind, a strange contradiction immediately appears. The buildings constructed for these fairs look anything but temporary. Vast complexes of monumental architecture stretch across entire city districts, filled with domes, towers, arches, and colonnades that resemble imperial capitals rather than exhibition grounds. The scale alone forces a question that rarely receives a satisfying answer. Why would anyone build cities of stone, glass, and iron for events meant to disappear? The official explanation is that these structures were engineering marvels of their time, made possible by new materials and industrial methods. Iron frameworks, prefabricated components, and mass labor supposedly allowed builders to erect enormous buildings quickly and cheaply. Many structures were described as temporary, often said to be made of plaster, wood, or lightweight materials designed only to last for the duration of the fair. However, surviving photographs complicate this narrative. Facades appear thick, and solid ornamentation is deeply carved, and proportions suggest long-term stability rather than short-term display. Even if some materials were lighter than stone, the level of craftsmanship visible challenges the idea of rushed or disposable construction. One of the most puzzling aspects of World's Fair architecture is how familiar it looks. Rather than showcasing radical new styles, many fairgrounds were dominated by classical forms. Greek columns, Roman arches, Renaissance domes, and Baroque ornamentation appear again and again across different fairs and different countries. This choice seems odd for exhibitions supposedly dedicated to modernity and the future. Instead of experimental architecture, visitors were presented with visions of an idealized past, rebuilt at enormous scale. This repetition raises the possibility that these fairs were not just displaying progress, but also repackaging older architectural knowledge under a new narrative. Speed of construction is another element that strains credibility. Entire fairgrounds were reportedly built within 2 or 3 years, sometimes less. These were not just single buildings, but full urban environments complete with roads, canals, fountains, bridges, power stations, and transportation systems. Even with today's technology, constructing such large and coordinated complexes in such short timeframes would be considered extraordinary. In the late 19th century, with limited machinery and slower communication, the accomplishment becomes difficult to explain without assuming a level of organizational efficiency rarely acknowledged. Electricity plays a central role in the mystery of World's Fairs. Many exhibitions are remembered as the first places where the public encountered large-scale electric lighting. The entire cities of light appeared almost overnight, glowing with thousands of bulbs, powered fountains, illuminated towers, and electrically driven attractions. Official histories often present these displays as experimental demonstrations, yet their reliability suggests fully operational systems rather than fragile prototypes. Power generation, wiring, maintenance, and safety all had to function smoothly for months. This level of electrical infrastructure implies planning and expertise that go far beyond simple exhibition purposes. Another unexplained aspect lies in the internal engineering of these structures. Vast interior spaces were spanned without visible support, using techniques that resemble permanent civic buildings rather than temporary halls. Giant domes covered areas large enough to house entire crowds, while glass roofs flooded interiors with light. These design choices required careful calculation of loads, stresses, and material behavior. The idea that such systems were built quickly, used briefly, and then discarded does not align well with the complexity involved in making them safe and functional. Demolition raises further questions. After many fairs ended, large portions of these architectural complexes were destroyed, sometimes within months. Public opposition was common, as visitors and local residents questioned why such impressive structures were being erased. Official reasons included maintenance costs, urban development plans, or the temporary nature of the buildings. Yet the deliberate removal of so much monumental architecture feels excessive if the structures were truly as fragile and disposable as claimed. In some cases, buildings survived and were quietly repurposed, suggesting that their temporary label may have been more flexible than advertised. Photographic evidence also presents subtle inconsistencies. Images of construction sites often show surprisingly small numbers of workers relative to the scale of the buildings. Heavy machinery is rarely visible, and the methods used to lift and position massive components are not clearly documented. While photographs capture only moments in time, the absence of expected industrial clutter contributes to the sense that something about the construction process remains unspoken. The repetition of similar layouts across different fairs deepens the mystery. Grand central avenues, symmetrical planning, monumental focal points, and ceremonial axes appear again and again. This consistency suggests the use of established templates rather than unique one-time designs. It raises the possibility that World's Fairs were not inventing architecture from scratch, but drawing from an existing body of knowledge that allowed rapid deployment of scale, environments. What makes these questions particularly compelling is that they do not require belief in fantasy or hidden civilizations. The mystery lies not in impossible technology, but in unexplained efficiency, organization, and continuity of knowledge. The world's fairs appear to sit at a crossroads between eras, blending traditional, monumental building practices with emerging industrial systems. This blend may explain why they feel both modern and ancient at the same time, familiar yet difficult to fully explain. As we move deeper into the history of these exhibitions, examining specific fairs, structures, and technologies, the gap between the official narrative and the physical evidence becomes harder to ignore. The world's fairs were not just showcases of progress. They were vast engineering experiments whose full story has never been clearly told. Understanding them requires looking beyond labels like temporary and asking harder questions about how such ambitious environments could be created, operated, and erased within such a short span of time. Asterisk, when we move from the general idea of world's fairs to specific examples, the mystery becomes more concrete and harder to dismiss. One of the most frequently discussed exhibitions is the World's Columbian Exposition, held in Chicago in 1893. Officially, it was designed to celebrate the 400th anniversary of Columbus's arrival in the Americas. In reality, it became one of the largest and most architecturally ambitious events the world had ever seen. Entire districts were constructed around a massive central basin, surrounded by monumental buildings that formed what came to be known as the White City. Photographs show vast classical facades stretching for miles, crowned with domes, columns, and sculptural details that rival permanent government architecture. The White City was described as temporary, yet its appearance tells a different story. Buildings were uniform in height and style, carefully proportioned and aligned along ceremonial axes. The symmetry alone implies extensive planning, surveying, and coordination. The scale of ornamentation raises further questions. Decorative elements were not simplified or symbolic. They were elaborate, three-dimensional, and consistent across multiple structures. Even if plaster was used on the surface, the underlying framework had to be strong enough to support this level of detail and withstand months of exposure to weather, crowds, and vibration. The idea that such precision could be achieved quickly, cheaply, and temporarily remains difficult to reconcile with the visual evidence. Electricity at the Chicago Fair adds another layer of complexity. The exposition is often remembered as the moment when electric lighting captured the public imagination. Thousands of lights, illuminated buildings, pathways, fountains, and interior halls. This was not a small demonstration. It was a fully integrated electrical system powering an entire city-like environment. Generators, wiring networks, maintenance crews, and safety measures all had to operate reliably every night. While electricity existed before 1893, the scale and coordination displayed at the fair suggest a maturity of electrical engineering that seems far beyond what is usually acknowledged for the period. Transportation within the fairgrounds also challenges conventional explanations. Elevated railways, moving walkways, and boats carried visitors across the vast site. These systems were not experimental prototypes, but functioning infrastructure used daily by millions of people. The logistics of installing, powering, and maintaining such systems within a short construction window point to a level of planning and expertise that feels closer to permanent urban development than to temporary exhibition planning. Paris offers another revealing case, the Exposition Universelle of 1889, famously marked by the construction of the Eiffel Tower, is often celebrated as a triumph of modern engineering. Yet the tower itself is only part of the story. Surrounding it were enormous exhibition halls, galleries, and pavilions built along the Seine, many of them monumental in scale and classical in style. 10 years later, the 1900 Paris Exposition expanded this vision even further, transforming large sections of the city into exhibition spaces filled with bridges, palaces, and technological showcases. The Grand Palais and Petit Palais, built for the 1900 Exposition, stand out as especially puzzling. Unlike many fair structures, these buildings were not demolished. They still exist today, serving as permanent cultural institutions. Their steel frameworks, stone facades, and vast glass roofs demonstrate engineering excellence that feels fully modern. If these buildings were intended to last, it raises the question of how many other temporary structures were also capable of long-term use, but were removed for reasons unrelated to structural integrity. The glass and architecture of these Paris expositions suggests a mastery of material behavior that contradicts the idea of experimental. Large glass panels were installed at scale, supported by intricate metal frameworks that balanced strength and elegance. Temperature changes, wind loads, and structural movement had to be carefully considered. These are not trivial engineering problems, especially when solved repeatedly across multiple buildings in a short time frame. The St. Louis World's Fair of 1904 presents a similar pattern. Once again, an entire monumental city appeared almost overnight. overnight. Classical palaces lined formal avenues. Fountains flowed continuously, and electric lighting transformed night into day. The fairgrounds covered hundreds of acres, yet the architectural language remained coherent and unified. This consistency suggests centralized planning and standardized construction, methods capable of producing large-scale environments rapidly. What is striking across all these fairs is the repetition of certain features. Domes large enough to enclose entire buildings, long-span roofs with minimal internal support, extensive use of water features, and integrated electrical systems. These elements appear again and again, regardless of location. This repetition suggests not isolated innovation, but a shared body of engineering knowledge that could be applied wherever the fair was held. Another overlooked aspect is the role of water engineering. Many world's fairs featured elaborate canal systems, artificial lakes, fountains, and waterfalls. These were not decorative afterthoughts. They required pumps, pipes, pressure regulation, and filtration systems to function continuously. Some cases, water features were synchronized with lighting and mechanical displays, indicating sophisticated control systems. The idea that such complex hydraulic infrastructure was installed temporarily and then dismantled raises obvious questions. About efficiency and intent, the workforce behind these projects remains surprisingly invisible. While millions of visitors were documented, detailed records of the labor force responsible for construction are often vague. Photographs rarely show the expected density of workers or machinery. This absence may be due to selective documentation, but it contributes to the overall sense that the full story of how these structures were built has not been completely preserved or communicated. The destruction of these fairgrounds continues to be one of the most puzzling elements. After the Chicago Fair, much of the White City was demolished or burned, despite public fascination and admiration. Similar patterns occurred elsewhere. If these structures were as temporary and fragile as claimed, demolition would be expected. But if they were capable of functioning as permanent civic spaces, their removal suggests motivations beyond practicality. Urban redevelopment, political decisions, and shifting cultural priorities may all have played a role, but the scale of destruction remains difficult to fully justify. Taken together, these examples suggest that World's Fairs were not merely celebrations of progress, but demonstrations of an engineering capability that operated at a level of organization, speed, and scale rarely acknowledged. They created entire cities, fully functional and visually unified, only to erase them shortly afterward. This cycle of construction and destruction creates a historical blind spot, where the physical evidence of extraordinary engineering was intentionally or unintentionally removed. As we continue to explore these exhibitions, the mystery becomes less about whether the engineering was possible and more about why it was framed the way it was. The label of temporary may have served to simplify public understanding, masking the true complexity and permanence of what was achieved. In doing so, it leaves modern observers with an incomplete picture of the technological capabilities that existed during this transitional period in history. Asterisk, as attention shifts away from the exterior beauty of World's Fair architecture, the mystery deepens inside the exhibition halls themselves. Machinery halls were often described as the beating heart of these fairs, where nations displayed their industrial achievements. Yet the scale and complexity of these halls suggest something far more advanced than simple showcases. These buildings housed enormous engines, turbines, dynamos, and mechanical systems operating simultaneously, often for months without interruption. The power required to run such machinery was immense, yet breakdowns and failures were rarely reported in official accounts. At the 1893 Chicago World's Fair, Machinery Hall covered more ground than many modern industrial complexes. Inside were massive steam engines connected directly to electrical generators, transmitting power throughout the fairgrounds. This was not a laboratory experiment or a controlled demonstration. It was a real, functioning power network supplying lighting, transportation, water systems, and mechanical displays across an entire temporary city. The synchronization required between generation, distribution, and consumption implies a deep understanding of electrical load management that feels strikingly modern. One of the most puzzling aspects is how quietly this achievement entered public memory. Textbooks often describe early electrical systems as unreliable and limited, yet the fairs contradict this narrative. Entire landscapes were illuminated every night, with lights outlining buildings, reflecting on water, and illuminating interiors without flicker or visible instability. For many visitors, this was their first encounter with large-scale electric lighting, yet contemporary reports describe it as smooth, awe-inspiring, and dependable. This reliability challenges the idea that such systems were still in an early experimental phase. Wireless and atmospheric phenomena also appear repeatedly in fair documentation, though they are rarely emphasized. Some exhibitions included demonstrations of wireless communication, electrical resonance, and atmospheric electricity. Towers, spires, and metal frameworks were often integrated into fairgrounds in ways that suggest more than structural necessity. While official explanations frame these elements as experimental or symbolic, their repeated presence raises questions about whether engineers were exploring methods of power transmission and environmental energy collection that were later abandoned or reclassified. The nighttime transformation of World's Fairs deserves particular attention. During the day, visitors saw monumental architecture and mechanical displays. At night, the same spaces became glowing cities of light. The emotional impact was profound, often described as otherworldly. This dual identity required infrastructure. Capable of handling dramatic shifts in power demand, modern cities struggle with such transitions even today, yet the fairs managed them seamlessly. This consistency suggests that the underlying systems were far more robust than typically acknowledged. Ventilation and climate control inside large exhibition halls present another unexplained challenge. Many buildings enclosed, vast interior spaces filled with people, machinery, and lighting, all generating heat. Despite this, accounts rarely mention unbearable temperatures or poor air quality. Large glass roofs, metal frameworks, and strategic openings may have played a role, but the effectiveness of these solutions points toward a sophisticated understanding of airflow, heat dispersion, and passive cooling. These principles are often presented as modern discoveries, yet they appear to have been applied at scale over a century ago. Transportation of materials to build. The fairs also raises unanswered questions. Enormous quantities of stone, metal, glass, and machinery had to be sourced, transported, assembled, and installed within remarkably short time frames. Rail networks played a role, but the speed and coordination required still feel extraordinary. In many cases, the same workforce moved from one fair to another across continents. Applying consistent architectural and engineering styles suggests the existence of an international professional class of builders and engineers, whose collective knowledge was far more advanced and standardized than commonly assumed.